Welcome to The Explainer. Today we are diving into a really big idea, one that could literally change the color of our world. We're talking about solar panels that can also feed plants.
So here's our roadmap. We're going to start with a pretty big problem, then uncover a really cool, transparent solution. We'll get into the science of how it all works, explore the rainbow of possibilities it opens up, and then look at what the future could hold. It's going to be good.
Okay, so the world is facing two gigantic challenges at the same time. We absolutely need more clean energy to combat climate change, right? And we need to feed a population that's getting bigger every single year. Greenhouses are great for the food part, but they use a ton of energy. So what if we could tackle both problems at once?
At first glance, putting solar panels on a greenhouse seems like a total no-brainer. You generate clean electricity, you power the greenhouse, perfect. But there's a huge catch. Your standard solar panels? They're opaque. They block the sun, and that creates shadows, which is the absolute last thing you want when your whole business is growing things that need sunlight to survive.
This puts farmers in a really tough spot, forcing them to make an almost impossible trade-off. You see, if you add more solar panels, sure, you get more clean energy, but you also get more shade, and your crop yield just tanks. Okay, so you use fewer panels. That means more sunlight gets through and you get a great harvest, but now you're not generating nearly enough clean energy. It's this constant battle between energy and food.
But what if you didn't have to choose? Seriously, what if we could have the best of both worlds? Well, it turns out a new generation of solar technology offers a really clever way out of this exact dilemma.
And here it is. The solution is a technology called a dye-sensitized solar cell, or DSSC for short. And what's so cool about this is that it's inspired by nature itself. I want you to think of it like an artificial leaf. It's flexible, it's semi-transparent, and it literally uses dye to capture sunlight and make energy, just like a plant uses chlorophyll.
But the real genius here goes way beyond just making a see-through panel. These cells do more than just generate power. They act like a smart filter for sunlight. And the science behind how they do it is, well, it's just fascinating.
So it turns out plants are pretty picky eaters when it comes to light. They don't just use the entire rainbow. For photosynthesis, the process they use to make food, they mostly absorb light from the blue and red parts of the spectrum. That specific zone is called photosynthetically active radiation, or PAR for short. That's the good stuff for plants.
And that right there is the core idea. Since we know exactly which colors of light plants crave, we can design these solar cells to be incredibly selective. The dyes inside are specifically chosen to soak up the parts of the spectrum that plants don't really use anyway, like green and yellow light, and turn that into electricity. This lets all that crucial red and blue light, the PAR, pass right on through to the crops growing below. It's brilliant. The process itself is this elegant little continuous loop. So, first, sunlight zaps the dye, getting it all excited and knocking an electron loose. That electron then gets pushed through a circuit, and boom, that's your electricity. And finally, an electrolyte solution comes in and sort of resets the dye, getting it ready for the next bit of sunlight. It's this constant microscopic dance, just turning light into power over and over again.
Now, this is where the technology gets even more versatile, because it turns out you can use all sorts of different dyes. It's not a one-size-fits-all kind of thing. You can literally pick your panel's color to get the job done right. Scientists basically have two main options. On one hand, you have synthetic dyes. These are super efficient, they last a long time, but they're expensive and can contain some not-so-great heavy metals. Then you have the other option, natural dyes. These are way cheaper, totally eco-friendly, but they're a little less efficient and don't last quite as long. Having this choice is a game changer. A big high-tech farm might go for the synthetic efficiency, while a smaller community garden might choose the low-cost, green-friendly natural dyes.
And when we say natural, we really mean it. We're talking about dyes that can be pulled from things like flowers, from leaves, beets. You can even get them from turmeric. Yeah, the stuff in your spice rack. It just means the color and the special light filtering powers of a solar panel could one day come from plants you can find right in a garden.
So all of this sounds pretty incredible, right? But what's it going to take to get these transparent solar panels out of the lab and onto farms and maybe even into our cities?
Well, as with pretty much any new technology, a big hurdle is cost. If you look at this breakdown, the sealing parts and the dye and electrolyte itself, that makes up almost 70% of the total manufacturing expense. So figuring out how to get those costs down, that's going to be the key to seeing these things everywhere.
But even with those challenges, the potential here is just enormous. As the researchers behind this work put it, we're looking at a future with more productive farms that are also helping to power our world and slash carbon emissions. That's not a win-win, it's a win-win-win for food, for energy, and for the climate.
And you know, this isn't just some science fiction pipe dream. The innovation behind this dynamic DSC mini greenhouse idea has already been winning multiple international awards. That tells you that the experts out there see its incredible potential to completely change how we think about farming and energy.
And that really leaves us with a final powerful thought. I mean, this whole thing starts with greenhouses, but what if we applied this idea everywhere? What if we started rethinking all the surfaces around us, our windows, the facades of our buildings? We could transform our cities into living, breathing ecosystems that actually help sustain us. What a future that would be.